operation of NMOS depletion MOSFET or operation of the NMOS depletion type MOSFET. And introduction is before going on to the topic, we have to know what is MOSFET. MOSFET stands for metal oxide semiconductor field effect transistor. The MOSFET is one type of special device which is used for specific and special applications. The MOSFET is generally used for high switching speed operations. The MOSFET is a solid state device and it has comparatively high efficiency than a bipolar transistor. It can be classified into two parts as per their working, which is classified as depletion mode and enhancement mode. And there are also different types of transistors as per the channels, which are P channel depletion type mode, N channel depletion type mode, P channel enhancement type mode, N channel enhancement type mode. And this is the basic structure of N channel depletion type mode. In this we can see this is a N channel MOSFET and it is connected to two N wells through a P substrate, and this is the metal which connects through gate or from drain to source. And what is depletion mode in MOSFET? This is not exactly the same definition that the depletion mode transistor or MOSFET channel is pre-built in the MOSFET. In this type of MOSFET, we apply a gate source to turn off the MOSFET. The depletion mode is nearly equal to normally closed switch, which is the MOSFET is always on condition. When we apply voltage difference between drain and source, will start flowing through the MOSFET. Depletion MOSFET is also further divided into two types according to their pre-built channel. If P channel is pre-built, then it is called as P channel depletion type MOSFET. If N channel is pre-built, then it is called as N channel depletion type MOSFET. So now we will see the structure of the pre-built of the NMOS. This is the structure of the pre-built of the NMOS depletion type MOSFET. I have showed you before. And in the NMOS structure, there are different types of in this type of depletion MOSFET. The source, the drain are connected to a small strip of N-type semiconductor. The substrate is used in the MOSFET and is a P-type substrate, and the electrons are majority charge carriers. And the N-channel depletion type MOSFET, the MOSFET construction is same as compared to enhancement type, but in enhancement type the work is dissimilar. The gap between the source and drain terminals is composed of N-type impurities rather than P-type impurities. And if we let us see the substrate here, when we apply a small potential difference between the terminal like source and drain, the current flows through the N region of the substrate. When the negative voltage is applied at the terminal of the MOSFET, the carrier charges like electrons will be repelled and moved down with the N region under the dielectric layer. So the charge carrier's depletion will occur within the channel. Overall, the overall channel conductivity gets reduced. At this condition, once the same voltage is applied at gate terminal, the drain current will also be decreased. Once the negative voltage is increased further, reaches the pinch off region. Thus, here the drain current is controlled by changing the depletion charges of the MOSFET. So it is called as depletion MOSFET. Here the drain terminal is given positive potential and the gate is given negative potential. So the source is at zero potential. Thus the voltage variation between drain and the gate is high as compared to the source to the gate. So the depletion layer width is high to drain as compared to the source terminal. The characteristics. Now let us go to the characteristics of N-channel depletion type MOSFET. The drain characteristics of the N-channel depletion type MOSFET are as this. are as shows below. Here the characteristics are plotted between VDS and IDS. When we keep increasing the VDS value, the ID will also increase. After a certain voltage, the ID becomes constant and the saturation current value for the VGS is equal to 0, and thus it is called as IDSS or IDSS. Whenever the voltage is applied in negative, then this voltage at the gate terminal will push the charges carriers like electrons to the substrate, and these holes within the p-type substrate will be attracted by these electrons. So due to this voltage, the electrons within the channel will be recombined with the holes, and the rate of recombination will depend upon the negative voltage applied. Once the increase of the negative voltage, the recombination will also increase, so which will decrease the number of electrons within which the channel will reduce the current flow effectively. When we observe the above characteristics, it is seen that when we increase the VGS value negatively, then the drain current will also decrease. At certain voltage, these negative voltage will be 0. Thus, it is called as pinch off voltage. This MOSFET is also works as the positive voltage. So, when we apply positive voltage to the gain terminal, then the electrons will be attracted to the N channel. So, the number of electrons within this channel will increase. So, the current flow within this channel will also increases. So, for the positive VGS value, the ID will also be even more IDSS. So this is the characteristics. We can see here how the depletion type and enhancement types works. So this is the drain characteristics of MOSFET. Now let us go to the transfer characteristics of the N-channel depletion type MOSFET. The transfer characteristics of N-channel depletion type MOSFET are shown as similar to JFET, where the characteristics define the main relation between ID and VGS for the fixed value of VDS. For the positive VGS value, we can also get the ID value. So due to that, the curve in the characteristics will extend to the right hand side. Whenever the VGS value is positive, the number of electrons within the channel will increase. When the VGS is positive, then the region in the enhancement region similarly to the VGS is negative, then this region is also known as depletion region or depletion mode. We can see here the main relationship between ID and VGS can be expressed through ID is equal to IDSS into 1 minus VGS by VP whole square. By using this expression, we can find ID value from the VGS. Now let us go to the applications. Applications of N-channel depletion type MOSFET. The depletion MOSFET applications are that the depletion MOSFET can be used in constant current source and linear regulator circuits as a pass transistor. These are extensively used in startup auxiliary power supply circuit. Normally, these MOSFETs are turned on when no voltage is applied, which means they can conduct current in normal conditions. Thus, this is used in digital logic circuits as the load resistances. These are used for the flyback circuits within PWM ICs, and these are used in telecom switches, solid state relays, and many more. These MOSFETs is utilized within voltage sweeping circuits and current monitoring circuits and LED drivers and etc.